Hello guys, welcome back to ECU TechNest. In this lecture, we will be discussing about the module 3 of digital image processing. So, the module is based on image restoration. So, what is image restoration? Image restoration is the attempt to restore the image that have been degraded and also to identify the degradation process. It attempts to reverse the process by extracting the original image from the degraded image, or we are going to restore the image. And the next one is image. What is the difference between image enhancement versus image restoration? Image enhancement is we are improving the quality of the image, whereas in image restoration we already have the blurred image. We are trying to remove the noise in the image and get back the original image. And image enhancement is subjective to nature, whereas image restoration is objective process. Although restoration involves modeling of degradation and applying the inverse process in order to recover the original image. Next is degradation model. Degradation model is represented and the main objective is to restore a degraded or a distorted image to its original content and quality. So f of x comma y is the input function, that is the image, and h is the degraded function, along with the noise, that is n of x comma y, and the restoration filter, that is g of x comma y. The output that is obtained is f cap of x comma y. So in the spatial domain, it will be represented as g of x comma y is equal to h of x comma y into f of x comma y plus n into n of x comma y. In the frequency domain, x and y is converted to u and v, and therefore the equation would be g of u comma v is equal to h of u comma v into f of u comma v plus n of u comma v. In terms of matrix, it is represented as g is equal to h into f plus n. Next, we'll discuss about the characteristics of this equation. If the value of h, that is the degradation function, is linear, the position is invariant process, and then degraded image will be in the spatial domain, and star here represents convolution. Next, coming to image restoration. In image restoration, we are trying to recover the image that has been degraded by using a prior knowledge of the degradation phenomena. And this is a quick recap of what we have learnt. That is, spatial domain techniques are particularly used for removing random noise, whereas frequency domain techniques are particularly used for removing periodic noise. Next, we'll discuss about what is the principal goal of image enhancement. The principal goal of image enhancement is restoration, and it is the technique which is used to improve the quality of an image and also some predefined values. So the approach usually involves formulating a criteria of goodness that will yield an optimal estimate of the desired result. Next is estimation of degradation model. There are three ways to estimate the degradation model. The degradation function is represented as h, and there are three ways, that is by observation, by experimentation, and by mathematical modeling. So after approximation the degradation function, we apply the blind convolution to restore the original image. And next one is observation. No knowledge of the degraded function is given in this case. That is, observation is done on g of x comma y, and we try to estimate the degraded function in the region which has a very simpler structure, and gs of x comma y implies gs of u comma v. That is, it is converted from spatial domain to time domain, and fs of x comma y is equal to fs of u comma v. Similarly, h is equal to gs of u comma v divided by fs of u comma v. This is because there is no noise in this case, therefore n is equal to 0, and the equation will be h is equal to g by f. Next is through experimentation. We are trying to image the setup that is similar to original one, and along with the impulse response and impulse simulation, We have to observe and find the value of h which has similar result as that of degradation function and try to get the original image. So the mathematical modeling is represented as h of u comma v is equal to e power minus k into u square plus v square divided to the power 5 by 6, where k represents the constant that depends on the nature of the turbulence. Next, this we have already discussed. This is the model of image degradation or image restoration. Next, we'll discuss about noise model. So this is one very important question that is asked in VTU Sem exams as well as in multiple other exams. So they'll directly give the question, explain about noise models in detail, or they'll specifically mention which noise model to explain. So noise model or the image noise is the random variation of brightness or color information in images, and is usually an aspect of electronic noise. And image acquisition example would be light levels, sensor temperature, etc. And for transmission example would be lightning or other atmospheric disturbances in the wireless network. And noise model in digital image arises due to image acquisition and image transmission. So during image acquisition, the conditions would be environmental conditions and also the quality of sensing, whereas during transmission, it is the interference during transmission that takes part, and it is very important for the noise model. So these are 7 important noise model or noise probability density function. They'll ask in exam to explain any 2 to 3 noise model in detail, or they'll generally ask explain about noise model in detail. So the noise models along with their probability density function should be explained. So there are 7 noise model: Gaussian model, relay model, Erlang or gamma noise model, exponential noise, and uniform noise, impulse noise. Impulse noise is also called as salt and pepper noise, and the periodic noise. We'll discuss about this in next lecture. Thank you.